wants to sit here for 2 hours, right?
Question already.
Oh, go ahead.
Did you restart the recordings?
Did I restart the recording?
Yeah, he did.
Yeah, he
process here.
Great.
Did you share your screen though?
Oh, good call. Thank you.
I didn't see the yellow.
Share my screen. Share your desktop. To see everything on your monitor. Yeah, that's great. Okay. Software design in 2018. Adjust your thinking and raise your bar. Or raise the bar. I'm Mike Wisniewski. Again, questions are welcome. Let's try and keep debate though offline. Happy to talk about any of this stuff with you after the presentation if you'd like. So, let's get started. So I've been in the software world for about 20 years now. And with my tenure at Progressive, I worked in the quoting platform, in the product platform, and in the servicing platform. As Aaron mentioned, I'm currently a solution architect on the Servicing 2 website project. And at times during this presentation, I may refer to something I call traditional web developer, and I'm including myself in that context, so please don't get offended if I say traditional web developer, referring to myself, okay? And then last thing, since we're talking about the past in traditional web development, anyone want to take a guess around what time frame this desktop is from? What year though?
25?
I'd say 2000.
Oh, Windows NT.
You guys are all real close.
No.
2000 is close
2000,
enough. It's
yeah.
technically 2001, which is when I started at Progressive. And the clues that give it away are you've got Windows NT Workstation, IE 5.5. Ooh, that hurts. IE 5.5, Internet Explorer 5.5. Not listed here, but at the time we were using IIS 4.0. Okay. All right, so current trends that are going on out there in the industry right now that have a heavy impact on things that we're doing at Progressive, kind of 4 big trends: the client API design paradigm, open source software development, CI/CD practices, and cloud. And we know these are important because of the influence they're having on the program Servicing 2, Claims Next Gen, IAQ, Mobile Native Program. Now, I'm not going to sit here and talk about these 4 trends, though, and go over them because no doubt you've heard about them all already, and you would be really bored after an hour, and that's not my objective. So I'm not going to dive in. Instead, I'm going to go a layer deeper and talk about, well, how have these trends kind of impacted the way we approach software development in 2018. And the reason why is because it's really easy to go and work on a new project or learn a new programming language, but just fundamentally changing the way you think about something or the way you approach something, that's really difficult, right? It's not easy to do, but it's necessary. If we want to raise the bar, changing the way we think and the way we approach software development is necessary in 2018, especially if you're a traditional web developer like myself. Okay. Click on each one. Okay. No, Mike. Okay. So instead of going through trends, I'm going to talk about 10 software design principles that I've kind of created. Some I've taken from industry leaders, some I've created on my own. But I'm going to walk you through these 10 principles that are a layer deeper that explain how we can change our way of thinking about these trends and how they influence what we're doing at Progressive. And no, angular learning curve is not the first principle, if anybody was wondering that. But it's where I'm going to start with because it intros me into my first principle. So, has anyone heard this, that when they get on a new program like Servicing 2 or Claims Next Gen, there's this angular learning curve? You guys heard about this? I know I've heard people say that. And it's kind of strange because Angular is just one piece of the client development world. I mean, it's actually not even the most challenging one. I would say RxJS or probably Redux is a little more challenging for people to pick up. But the whole thing is kind of a misnomer because we use lots of libraries to build our client application. And that drives me to my first point, that the world is moving away from these big multi-purpose frameworks. So if you're a traditional web developer, you may be used to opening up Visual Studio when you come in the morning and everything's there that you need to develop your website, right? You don't need to go download all these different packages. You got everything you need there. And the world is changing. We're moving away from these big multi-purpose frameworks to these smaller, single focused libraries that we use to assemble our application. And the reason we're moving that way, or the industry is moving that way, is that if you think about, say I want to use a new feature, and that feature is only in the new version of .NET, why do I have to upgrade my entire .NET framework just to take advantage of that one little new feature that's in the new version of .NET? If you've got more single focused libraries, you can also get the backing of the open source community. So you've got all these developers that are giving feedback on these small single purpose libraries, and you get a better quality end product based on that. Does that make sense? Okay, so first thought principle is, and this sounds weird to say, think in small, reusable, tiny packages. Doesn't roll off the tongue, though, does it? So if you're using small, reusable, or developing using small, reusable packages, the first concept you need to know about is something called a package manager. So on the left are these a few example package managers that are out there, and you would use these to you'd use these package managers to pull in dependencies, these small, reusable, single-focused dependencies into your application. Now, at Progressive, we don't interface with those directly. We use something called Artifactory, which is kind of like a proxy to using these package managers. And note, package managers are not something new. They've actually been around for a very long time, but with the emergence of open source software development and Progressive's kind of adoption of open source, that world has kind of exploded. And then real quick, the last thing I'm going to tell you is that if you take a look at this bottom right-hand screen, that's an image of our package.json file in the Service2 website application. As you can see, it's gigantic. I can't even fit everything on one screen, all of the dependencies and libraries we're pulling in. If you look at that little preview pane window, it's gigantic, that list. So when we pull in our dependencies, that's the thing that actually interfaces with Artifactory, and then we pull in our library. So as you can see, we're building a client application based on all these single focused libraries. And you can almost think about it as like the single responsibility principle on steroids, right? Okay, and then the last point I want to make about this is it's not just about open source third-party libraries. You can also reuse your own library. So in Servicing 2, we've actually we built an analytics library, and we built a UI library, and we've actually uploaded those things, published them to Artifactory, and then apps can pull them in as dependencies, just like any other open source library. Okay? So away from these big frameworks into smaller, focused libraries. Okay. Has anyone ever said this statement before? Oh, we got a question?
Well, I was just wondering, so we do, like on Servicing 2, you mentioned that we do that where we take some of these core concepts and we pulled them out and put them into their own libraries.
Mm-hmm.
Like, how far should you go down that trail, do you think? I mean, because you could do that, you could take every feature and make it its own library as well. So how do you, where do you draw the line there?
I can't say there's a right or wrong answer to that. I would say whatever you intend on reusing. So I wouldn't pull that out and make it its own library if I wasn't really intending on reusing that library in multiple places.
Okay.
So moving on to my next principle. Has anyone ever said this statement? We don't need comments or documentation. the code should be self-documented. It's a really popular phrase traditional web developers used to say. I've said it. Anyone else want to be brave and admit they've said this? All right, great. You guys are alive. Got a loud crowd here. So in developing software in 2018, I still believe that code should be written well, and if you write it well, it should be self-documenting. But in 2018, documentation is now vital. So think about that previous subject we just discussed. We talked about all these small libraries we're pulling in and reusing them. If I had to go read the code for every single one of those libraries because there was no documentation, I'd be doing nothing but reading code. I'd never get anything done, right? I just don't have time for that. So documentation is really important now. Think about if I needed to call an API. Maybe I needed to call this address standardization API that EXD provides. How am I going to know what the request and response is supposed to be? Think about the nature of a HTTP request and response. It is free form. So without great documentation like Swagger, we'd never know. I'd have to go read that code, and many times I may not even have access to that code. I might not have access to the EXD code. I don't know what their code's doing. So documentation is so important in this world now to be more efficient in 2018. The accuracy is important. I'm really surprised how many times I get testers come up to me and say, hey, Mike, your Swagger doesn't match what the API is actually responding with. So we got to be taking this much more seriously now. And then the last really cool example I want to bring up, just because I want to brag a little bit, this bottom right-hand image is actually a markdown file. So our standards and best practices in servicing 2, we actually write them in markup or markdown, markdown that actually lives with the code in the same repository as the code. And because of that, because it's not on a Word doc somewhere out there in some SharePoint, people are actually maintaining this and actually using it. So documentation is vital now. You're not going to have time to go and read everyone else's code and just figure it out on your own. And accuracy is very important too. All right, let's move on to my next principle. Another great saying. Who wants to be brave and admit they have said this? Prototype code ends up being production code. I've said it.
Said it or
Yeah. Yeah. And in the traditional web development world, we'd say this with kind of like this negative connotation to it, right? Well, in this new world, I'm going to tell you that not only does prototype code end up going to production, we encourage it, but we encourage it with proper verification, proper testing. So prototype code ends up being production code. And why? Because we always need to be production ready. So this is my third principle. Always be production ready. And it kind of escapes people. What exactly does that mean? Always be production ready. What does that mean? So if we're using continuous development practices in this new world, there's this expectation that at any point our code could just get pushed into production. So we always need to be production ready. But what does that really mean? What does that imply? What do we need? How do we need to change the way we approach software development? The first way is production readiness. So we had in servicing 2, somebody writes a call to an API, and they only made that configuration or hard-coded to call the dev version of that API. Said, oh, we'll just worry about it later, right? There will be a production readiness phase later, right? Well, guess what? In the new world, there's not really this heavy, big phase late in the project with which to get things ready for production. So luckily we caught it, but if we were always being production ready, when we write the code, we'd actually do that as we'd add the production configuration entries as we write the code. So you need to be doing production readiness every iteration, and some folks would argue every build, and some folks would argue even every story card, you should be practicing production readiness. Who knows if there will be a later phase? You don't know that. Your code could go up at any time. So the next big thing that we need to change the way we think about to always be production ready is code management. So how the heck are we going to do this? Now, a traditional web developer may be working on a waterfall project, or even on agile projects. I've seen this, where you've got maybe multiple teams working on a project or code base, and they don't integrate together till very late in the project. Maybe like 3 weeks out from when you're going to production, and they expect to catch everything, integration issues, all of that. And a lot of times this caused a lot of problems. You can't be production ready if you're merging code late in the process. So a lot of people out in the industry, and even a lot of projects here at Progressive now, so Servicing 2, we use this. So does Claims Next Gen. I'm not sure of the other programs that they use this. So we've altered the way we have approached code management. We use something called Git flow, and there's other branching strategies out there, but you need to alter the way you manage your code if you always want to be production ready. So we use Git flow in Servicing 2. I'm not going to tell you what the right branching strategy is for you and your project, but it is a consideration you'll need to think about if you always want to be production ready. Okay, probably even more important is testing. There's no big release testing phase at the end. Who's here has heard of the term move testing to the left? Good. I hear this term, move testing to the left, move testing to the left. It means there's not going to be this big phase later, so I need to be testing in full up front when I'm developing my code or shortly after that code is done. And I need to alter probably my strategy of how I approach testing and how I approach automation. And up here's an example from Servicing 2 of our automation strategy. I'm not going to say that this is the right strategy. Every project is different. You've got to pick an automation strategy that is right for you. But if we always want to be production ready, we need to be altering the way we approach testing and automation. And then last thing about always being production ready. Does anyone know what this is, by the way? Both of these images, where they're from?
That's Fail Whale from Twitter.
That's right, Fail Whale from Twitter, and actually this image down here is from Twitter as well. I love the Fail Whale. But anyways, that's a whole other subject. So the last implication of always being production ready, if I think of when I was a very junior developer, traditional web developer, I'd be like, I'm just going to write this code and we'll test it later and we'll figure out the ways it can break later, right? Well, if I'm always being production ready, there's no later. There is no later to figure out what could go wrong with my code. So we need to be considering, as we're developing code, what are the failure points? And we should, I don't want to say force the discussion, we should broach the subject with business. So if you're sitting back and you're expecting business or some higher power to say, here's the requirements of how you should handle this failure scenario, they don't know that. They're not in the code with us. They don't know what the failure points are. So it's our responsibility as IT professionals to be having this conversation or broaching this conversation with business. There's one point I wanted to make about the previous slide, the automation testing in this slide. I've actually had developers say to me, wow, this is a lot that I need to be responsible for now. And my response to them always is, yes, it is. That's why software professionals command such big salaries. So earn your pay. You guys were supposed to laugh a little more about that. Thank you. All right. Let's move on to the next principle. So speaking of what could go wrong, this leads me into my next principle, design for graceful degradation. So in the old world, you had an HTTP response, HTTP request, and Normally, you'd only had one of those when you're serving up a web page, and all of the content and the data would all be embedded in one HTTP response. And in the new world, if you're doing like a client API, sometimes you have lots of calls back and forth, and you can get kind of chatty, right? So one of the biggest things that could happen is you could lose your connectivity. That's a big deal now, especially now that we've got all these mobile devices out there in the world. So we need to consider that in 2018. Now, there's this concept out in the industry, I'm not going to dive deep into this, called progressive web apps. It has nothing to do with the actual company Progressive, PWA. Who's heard of progressive web apps? Anybody? Good. Now, what progressive web apps mean? So think about when we did responsive web design for the first time. And people said, well, responsive web design is about doing mobile design first. So I love this analogy because now people with PWAs, they say, design for offline first. I love that, but design for offline first, right? Browsers are just now coming up with or finally supporting the features to be able to do a PWA. And the main tenet of a PWA is you kind of preload all of the data you need and then save it somewhere in the user's browsers. There's lots of different mechanisms for which to save it. But then when the user finally uses the app, it doesn't matter if they've got a connection or not. I've already got the data cache that I need to do to use or to show the app and to function like it's supposed to be. So, am I suggesting you all run out and implement a PWA? No, I'm not suggesting that. But in 2018, if you are writing a serious web app, you need to consider what can go wrong, especially connectivity. We'll talk about some other examples in a second, but especially connectivity. If you look on the left-hand side of this slide, here's a great image from the quoting application. So when you submit that form, and they see that the API call failed, they look and see, does this person have a connection issue or not? And if they do, they don't send them to a tech div. Tech div page is one of the worst experiences you can give a customer. It will cause them to abandon your site like crazy. Business hates tech div. I can justify that. Trust me. So instead, they show up this little banner, hey, we think you lost your connection. Better go check it. I'll even give you a retry button. This is a really nice example. But designing for graceful degradation is not just about connectivity. It's also about other things, just considering all your failure points and do we want to gracefully handle that a little more gracefully? So on the right-hand side is an example from Servicing 2. In Servicing 2, we have a multi-policy servicing experience, which means if you have multiple policies, we retrieve all of those policies up front. Now, let's say you've got 3 policies and I'm only able to retrieve 2 of those policies and the third one fails to retrieve. Yes, it is true, once in a great while, policy retrieval fails. It's a true statement. Very rare, but it happens. So we cleverly talked to business about this and said, hey, we don't think we should be throwing them to a tech diff in this scenario. Is there something we could do differently? And they said, yeah, let's go back and think about that. That's a good idea to show, hey, that I wasn't able to retrieve this policy. It's temporarily unavailable. Another great example, documents. Documents is not vital to me servicing a policy. So when you go to our Documents Hub page and we try to retrieve the list of documents for EC, if we're unable to, we want a better way to handle that than giving them a tech diff would be able to say, sorry, your documents are currently unavailable, try again later. So that's the whole idea behind design for graceful degradation. How are we all doing? How do you guys feel? I'm feeling great. I'm feeling a little bit better. So, okay. Next principle. Build APIs for multiple clients. It sounds so simple, doesn't it? Build APIs for multiple clients. So, in the old world, in the traditional web developer world, I didn't really have to worry about this, right? I didn't build APIs that were meant to be reused. I had an application and maybe it had several layers to it. the way I've seen traditional web developers, including myself, when they first come upon this whole client API development paradigm, they think, well, maybe I just need to treat this like I did the old world, and I'll figure out how to break up this logic into multiple layers. And sometimes we get that layer wrong. So I've said this a lot the last 2 years. Pretend like you're building an API for multiple client applications. Some of them may not know anything about what data you're giving to them or the business domain or anything like that. It's a great example. Say I've got an API that needs to return a billing status. And my application's got a billing status code. Maybe it's 01, 02, 03, 01 means paid in full. Now what if I told you also that depends on your policy status? So policy status of 05 plus a billing code of 01 means paid in full. If I return those codes back to my clients, they're going to have to know the combinations for which billing status to show within their application. I'm expecting them all to code them. So let's say one of those clients is a third-party API outside of Progressive. How are they going to know what our billing codes and what our policy status codes mean? They have no idea. So a much better design would be to return a property from my API that says billing status and actually have that message in there, paid in full. Does that make sense? Okay, good. Beat that like a dead horse. So if you build your client and your API together in one project and at the same time, sometimes you have this problem where people put things in the wrong layer. Now, there's another way you could do this. You could build your API and your client separately. Have two separate teams build those clients. And there's a trade-off there. I'm not going to tell you which one is right and which one is wrong, but if you build it such that the API team is working differently from the client team, you could end up with this bridge scenario that I've got on the screen where they don't meet in the middle like they're supposed to. So again, I'm not going to tell you which one's right and which one's wrong. There's trade-offs to both of them. But I'm going to say this again. This is why Swagger is so important. Up front, agreeing upon a contract so you don't miss when you come together. And I've got some other considerations when you are building an API for multiple clients. First thing, if you put tags in your API content, maybe I've got an API and I've got a HTML front-end client that's using that API, and I put tags in it because they want tags in it. Now, a few months later, a native app comes along and they try and use that API. Are they going to be able to? No, a mobile native client knows nothing about HTML tags. So don't put HTML tags in your API responses, please. Okay? That's just my word of advice. You don't have to listen to it if you don't want to. But you're going to do yourself a favor. Now, there may be another solution to that. There are different layers of APIs, different types of APIs. That image I've got on the bottom right is actually from the EA guidance catalog, and you can read up all the different layers and types of APIs. I like to simplify this when I talk about it. I say there's business APIs that are intended to be reused, line of business APIs, and there's experience APIs which are not intended to be reused. They're specific to a specific client, and they're not intended to be reused. So you could, I'm not saying you put tags even in this, but you could write an experience API that tailors that data specific to your client's needs. So there are different types of APIs you could use, and you can consider that when you're building for multiple clients. And then the last thing I'll mention about building for multiple clients is I'm not going to tell you what API versioning strategy is the right one. There's lots of ways of doing it, but you have to have an API versioning strategy. If you do not, you will make changes that break the interfaces of your APIs, and then clients will be broken. You've got to have some sort of API versioning strategy. Make sense? Oh, go ahead.
Do we have a depreciation strategy for removing fields and things like that?
Good question. Beyond the scope of this presentation, but it's a very good question. Yeah, there's a lot of times that's why you've got an API management system, so you can actually reach out or you can track, is anybody using this old version of this API? If you're using some sort of API management software solution, you can actually see are there people hitting that old version of that endpoint. That's one way to handle it. All right. Moving on to the next topic, layered security in this new world. You know, security analysts, I want you guys to all go after this presentation and thank your security analysts. That is a thankless job, and they do a heck of a job at it, I will tell you. That's a thankless job, but they do an awesome job at it. I feel bad for those guys, I really do. But anyways, so the way we think about security, we have to, there's some new considerations in this new world. First off, when you've got a client and an API, all the data you return from an API to your client, people can go and see that. They've got access to that. Now, you could try to encrypt it, but even encryption is foolproof. People can get access to the data you're sending back from an API. So you want to be very careful about what kinds of data you return back. If it's something you really want the user to see, if it's not, you should not be returning that back to the client. Now, that's from the client end, thinking about how we want to return data. Let's take a look at then from the API side. So if you think about, let's say I've got an API and I've got different types of users using my API. In this new world, so I'll use servicing 2 as an example since that's the best example we have. When you log into our website, you get issued a security token. And in that security token, got highlighted in red, we've got embedded the roles that progressively embed our LDAP roles in that security token of the type of permissions or roles that user has. Now, let's say I've got an endpoint where I've got a CSR using an endpoint versus a low authenticated user in a client calling an endpoint. I would not want to return back all of the driver's license numbers from that endpoint to the low authenticated user, right? Even if the client were filtering that out, I wouldn't want to do that because the user can see everything you're sending back and forth. So we want to practice something called fine-grain authorization. Have you guys heard of this term, fine-grain authorization? It's a great one. If you haven't learned it, you'll really impress your security friends if you learn this term. Go impress them at a party. Can you imagine that, a party with security analysts? Hey, don't worry about it.
They didn't let me in.
They didn't let you in. Nice. Yeah, that's good. I like that. So that's part of fine-grain authorization. And this can also apply to actually being able to call endpoints and verbs within endpoints. Let's say I've got a endpoint in my API that allows a user to change the coverages on a policy. And I've got a low authenticated user. Well, I want to practice fine-grain authorization and say, hey, that low authenticated user, they looked in the network tab and they saw all the APIs that were getting called behind the scenes. Now that they're, if they were, let me back up a second. Maybe they saw someone else's session and they saw the fact that, there's certain APIs being called. So you can open up the developer tools and in a JavaScript web application and see all the APIs that are happening. They know that this one API, it's possible for it to get called. And now they try to call that thing, and that's why we want to do fine-grain authorization, because if they are not have the proper role to perform that change coverage functionality, we can say, nope, they're not authorized to do that. So we want to practice fine-grain authorization. And then the last thing I want to bring up about security and the way something we want to think about when we approach security in this new world is data validation and protecting the data. So a traditional web developer will think about, well, I'm on the back end. There's this other application that's collecting all of the inputs from the user. I don't have to worry about validating that stuff, right? But that front-end app will do that. Well, in this new world, endpoints and connections are constantly changing very rapidly. So we don't know from one day to the next. The connections might change. And so we want to be doing validation at every layer. So let me give you an example to drive this home. In Servicing 2, we were building report a claim flow. And you could enter script tags in that report a claim flow in the client. The client wasn't validating that you couldn't enter that. And it would call Policy Pro API. Policy Pro API wasn't validating that you couldn't enter script tags. And then Policy Pro, once it collected all the claims data and submitted it, it would then call Claims API. Claims API wasn't validating that you couldn't put script tags in there. And it got all the way to ClaimStation. You could pull up this stuff in ClaimStation, look at ClaimStation, just by the input we had in our Servicing 2 website for that. So you've got to be, you can't assume someone else is going to be doing this stuff. You've got to be doing it at every layer now.
A quick question. When I think
Yes.
about the security issue, I think more about, pulling hundreds of packages from 15 million places across the internet. That seems like a much bigger risk.
Can you repeat the question for people?
Yeah, so Zach was asking about pulling in third-party libraries and security risk there. And there actually is a process that we put in place. I didn't list it up here because, again, I'm focused more about you guys and building software at Progressive. But if you want at Progressive, it's a lot bigger of a risk. We've got a process in place with which these packages, when we pull them in, get reviewed. I think there's some software that actually does a check against the package, and like if it's uncertain, it flags it for an actual human to actually look at it. I know there's a process around it. I don't know all the exact steps around it, but very valid points. If you were not at Progressive and you were out in the industry, you got to be very careful about what packages you're pulling in, what security flaws they have, so on and so forth. Okay. Moving on to my next topic, layered performance. How are we doing on time? Oh, great, I got plenty of time. Layered performance. So performance in this new world. Performance engineer, another job that I think is thankless. You should all go after this presentation and thank your performance engineers. They do a thankless job, but they do it so well, right? All right, so performance in this new world. I talked about the nature of an HTTP request and response. In the old world was you normally just made one HTTP request and you got one HTTP response back. And that's no longer the case. Now with these thick, heavy client applications and APIs, you could be making lots and lots of calls to the back end. And as a software developer, what is the most expensive operation you can do with your code? Make a network call, right? So there's lots of network calls potentially now, and they're very expensive. So there's several ways with which we can approach combating that. Caching is not a new concept, but it is one we need to employ a lot more aggressively now in this new world. There's other added benefits, like we talked about earlier, being able to deal with graceful degradation of our application. But the whole idea of caching is I'm going to call an API, and I'm actually going to store that data. I think I've got an example up there. It's kind of hard to read this slides of Servicing 2. We actually shove our ng Redux store into session storage on the browser. There's multiple ways or multiple places you can cache data that you're getting back from an API, but the idea is that you cache data that you get back from an API, and if you know that data is still valid and is not stale anymore, don't call the API again, use that cached data. And this doesn't just apply for the client. It also applies for the API side. If I've got one API that has to call another API, and you know that data hasn't changed, you can cache it. So in servicing 2, for example, we get a list of all of the open claims or all of the claims for a user when they first log in, and we know that that data is going to be fresh as long as the user doesn't report a new claim. So instead of having our API call Claims API, we cache that data and we just use it over and over and over again because there's zero reason to go and call claims again. Now, another way we can combat this is by queuing requests. So if I've got lots of requests, maybe I need to take analytics events. I need to call an API with all these analytics events that are happening. Now, instead of calling for every single event that happens, I could do some sort of queuing mechanism where I queue these analytics events, and then once the buffer gets to a certain size, then I can make finally the API call and send all these analytics events off to an API. Now, usually you can't use that technique unless it's something non-operational. And then the last technique we can use is async. So if you've got calls that don't hold up the flow of data in your application, or if you use an approach called ghosting, you can use asynchronous network calls in your application. Okay. Other things we have to consider about performance in this new world. Who loves really dumb Android devices? No offense, anybody that uses an Android device. Okay. Who loves iPhones? So we've got, you get the point. There's lots and lots of devices out there. They will never equal the power of what you've got on a server. So utilize that power of the server. If there are things you can calculate on the server that's not client-specific display logic, do it on the server. Do the processing on the server. Use the server with what it's meant for. The other thing to note is that you can perform aggregation on the server. Perhaps I've got a bunch of API calls I need to make to disparate systems. I could reuse like an experience API we talked about before and create an aggregate endpoint that goes and calls all these different APIs, gets the responses back, formats the data, mashes it all together, and that will help out with my performance. Okay, anything else before we move on to performance? All right, we're getting close to the end, so hang in there with me. We got 3 principles left. So, in this new world, we need to rethink the implications of deployment in this new world. So we're using continuous integration, continuous development, continuous deployment practices, and we're using a new branching strategy, and guess what? There's this expectation now that unfinished features may go to production, and that may be earth-shattering for a traditional web developer. You know, you're working on a project, maybe it's waterfall, you never put in a feature before it's done, ever, to production. In this new world, you should be comfortable with features going to production, even if they're not ready yet. That doesn't mean they're actually physically on in production, but that code can go to production. We use things like feature flags to allow us to do that, but not only do you need to change the way you think about this stuff, we need to get management, high management, and we need to get business partners comfortable with this idea of, hey, even though this stuff's not done yet, it's going to go to production. We're going to make sure it's not going to impact anything, so don't worry about it, but get them comfortable with doing this. Another option you have with putting features into production that aren't done yet is if you're using the 3rd level of the Richardson maturity model, and you're living by the glory of rest, you're using hypermedia. So you can use hypermedia to your advantage, and you don't give or provide hypermedia for things that aren't done or ready yet. Okay, so those are 2 ways you can help allow features to go to production even if they're not ready yet. And then I've already talked about this, but one of the other things we need to consider with deployments now in this new world is your APIs are interfaces. And because they're interfaces, they have to abide by the open-closed principle. If you make a breaking change to that interface, undoubtedly you will break clients. So you must be using an API versioning strategy. I think that's old. You guys know that by now, right? Great. I've got a smart crowd here, right? Colorado's a smart crowd. All right. Okay.
Let me quote you on that.
Yeah. Feel free to quote me on that. Yes, it is. It is. Okay. Next principle. Learn new programming paradigms. So why do we have new programming paradigms? As a traditional web developer, we didn't have these big client applications. Now, we may have been using design patterns like MVC, MVVM, MVP. You guys heard of all those design patterns? Yeah. So we may have been using those design patterns, and then this whole client API paradigm came along, and people realized those patterns kind of break down when you've got a big client application. So in place, in industry, people started coming up with these new programming paradigms with which to better manage large-scale client applications. And the reason we have these, if you ever tried to build a large client application not using these, it ends up becoming a mess really quickly. So you've got people changing state all over the place. You've got people updating views all over the place. It becomes this big, hairy mess. So these first three principles specifically have been developed to help us better manage large-scale client applications. Functional programming, unidirectional data flow, immutability. So the whole concept is, I know specifically who's allowed to update client state, who's allowed to update a view, and it's got a very nice flow, a very nice pattern to it. Make sense? Great. Now, the last one, the non-blocking asynchronous programming. Again, rise of this large client applications and human behavior. The way humans behave with each other or interact with each other and the way is the same way they interact with applications. They don't click something and sit there and wait. I know that when I click something and nothing's happened, I start clicking all over the place, right? I behave in a very async way. And when I have a conversation on the phone with Kevin here, and if I had to say, Kevin, I'm going to talk to you. You are not allowed to talk until I say I'm done. And then likewise, he had to do the same with me. That's not the way humans behave, and that's not the way client applications and people want to interact with client applications. So we've moved a lot towards this asynchronous programming paradigm in the client. And then likewise, people liked it so much on the client, they started doing it on the server. Microsoft, actually quite a while ago, implemented the async keyword in .NET C#. And a lot of the JavaScript on a server solutions use non-blocking asynchronous programming, which is nice because then you can write similar type code on the server as you can on the client. All right, last principle. Expect abstraction of anything operational. Take a drink of water here. So read the screen on the left from my Twitter feed. That came up on my Twitter feed a while ago. And I read it, and I'm like, John Papa, what are you doing to me? You want to write me to write a serverless function that lives in the cloud. How is that possible? What on earth does that mean? Serverless function that lives in the cloud? What is he talking about? And I had to do a little research to realize it's kind of a play on words. It does run on a server, but they've abstracted any knowledge of it running on the server from you. So you literally just write a function, plop it out there on the cloud, and it's serverless. Hey! It's not really serverless. It is running on a server, but they've abstracted that away so much that you don't even realize it. Now, you're probably wondering, how does this impact software design, what we're doing at Progressive? Well, I thought this was a really neat example of just the abstraction of all these operational things. So in 2018, the idea is that you should focus on writing your application, and you shouldn't have to spend a lot of time and effort on all of these operational nons, on all of these supporting, all of these supporting infrastructure type things. So Progressive has done a great job of bringing in a lot of cloud services for us to use. They brought in Splunk and App Dynamics, and I know we're using our own in-house instance of TFS and TFS Build, but Microsoft actually provides cloud versions of those services. In 2018, the smart developer will be using all of those services. They're not going to go out there and write their own build pipeline by hand. And the reason for that is there's already people, kind of like the single multi-purpose libraries, right? People have spent a lot of time and effort on building these services. I don't want to have to reinvent the wheel. I don't even want to think about the wheel. I want to write my application and not worry about this stuff. And you should expect the same. The industry is going to continue pushing the envelope on abstracting all of these operational things, and I expect Progressive will, in turn, start utilizing and bringing these things more and more in-house. Does that make sense? Are you guys still awake? Hey, you're not allowed to leave yet. Go ahead.
No, I'm coming right back.
Go ahead. I'm actually not, so don't worry about it. So,
A question from the chat.
yes.
That was asked very early, so this might be a reinforcing question. It says, do we as Progressive expect the small, focused, open source libraries and packages to come with automated tests plus test coverage?
Say it one more time.
And louder.
Do we as Progressive expect these small, focused, open source libraries and packages to come with automated tests plus test coverage?
So, yes. So most of these open source projects, you can go to GitHub, like from your package manager, and say, here's the repo out on GitHub, and you can go and look, and they should have tests with those things. Now, we don't run those tests. We're going to assume that they're running those tests as part of their software development lifecycle. But we personally aren't going to run their tests for them, but we expect that those libraries got their own tests. 2018, is anyone really writing software without tests? I haven't seen that recently. Is anyone? Kevin Babcock raised his hand. He is writing code without tests in 2018. All right. So to review my 10 principles, think in terms of tiny reusable packages. Documentation is now vital. We should always be production ready. Design for graceful degradation. Build APIs for multiple clients. Look at security at all layers. Reconsider performance at all layers. Rethink about the implications to deployment with your software. Learn new programming paradigms and expect abstraction of anything operational. Thank you for sitting through this hour with me and listening to me back and forth. Appreciate it. Hopefully you learned something. Let's raise the bar and let's change our thinking from being a traditional web developer to a modern web developer. Thank you guys very much.
Great job, Mike.
49 attendees. So we had 26 in the room and 25 on the phone. So that was pretty dynamic.
Oh, you're free to go. You don't have to sit here.
Presentation, right?
Yeah, I tell you what, why don't I respond to this meeting invite with my slides? Does that work?
Quick question. You mentioned something called ghosting earlier. That's really horrible to search on the internet for. So what is